On this channel, we are going to be educating us on basic difficulties students face while learning sciences. We're also going to deal with basic engineering, foundational courses, as well as basic medical courses. We encourage you to pay full attention to all our classes. Today we'll be looking at naming of binary compounds. What are binary compounds? Here we say binary compounds are compounds containing only two elements. Example of such compounds are like in this case we have nitrogen and oxygen, that's N2O4. We have SO3, that's sulfur oxygen and sulfur oxygen. Of course, these compounds are binary compounds because they are comprised of sulfur and oxygen, nitrogen and oxygen. Basically, we have a lot of them in chemistry, but for this class, I will just be using these two for my explanations. Before we delve into naming this compound, let's understand the IUPAC rules that guide the naming of inorganic compound. And this time around, we are looking at binary compounds. First rule is name the least electronegative element in a compound. What this means is you need to identify between sulfur and oxygen which of the elements is more electronegative and which is least electronegative. Also in this case, in nitrogen and oxygen, we also have to know the most electronegative and the least electronegative. So how do we do this? Now let's refer to the periodic table. This is the cutout section of the periodic table showing the elements of period 2 as well as the elements of period 3. You can see that arranged according to the atomic number, we have lithium, beryllium, boron, carbon, nitrogen with atomic number of 7, oxygen with atomic number of 8, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulphur, chlorine, and argon. Now, these elements are arranged according to periodic properties. The periodic properties of interest here is electronegativity. You can see that electronegativity increases across the period. This means that oxygen is more electronegative than nitrogen. Take note of this. And also it decreases, electronegativity decreases down the group. That means that oxygen is more electronegative than sulfur because electronegativity decreases down the group. So sulfur is the least electronegative. According to the IUPAC nomenclature rules, have been able to explain what electronegativity is and how it varies in the periodic table. So let's apply that. It means in the compound N2O4, from what we saw, nitrogen is the least electronegative. So we have to name nitrogen first. So in the compound N2O4, we have addressed these two atoms of nitrogen by saying dinitrogen. Now, how did we arrive at this 4? Let's see how we arrive at this 4. Look at the second rule. The second rule says, follow the name immediately by the oxidation number of the least electronegative atom. The least electronegative atom here is oxygen, so we have to determine the oxidation number of the least electronegative element here is nitrogen, so we have to determine the oxidation number of nitrogen in N2O4. This is what we do. The algebraic sum of the oxidation numbers of all atoms in a molecule is 0. That is to say, we would sum the individual oxidation number of each of these atoms and equate it to 0. This is how we do it. Now, the oxidation number of nitrogen in N2O4 is, there are 2 atoms of nitrogen, so we say 2 times N. We're trying to get the oxidation number of nitrogen, plus the oxidation number of oxygen is commonly -2. So -2 times 4, that gives us -8. So 2n minus 8 equals to 0. You look for what n is, so it gives us +4. So as such, we address that compound as dinitrogen 4. The third rule says end the name of the compound with the "ide" for the more electronegative element. The more electronegative element for this binary compound is oxygen. So instead of addressing it as dinitrogen 4 oxygen, we address it as dinitrogen 4 oxide. Look up to this also. This is sulfur and oxygen. From the explanation we showed before, sulfur is the least electronegative when compared to oxygen. So we first named sulfur in this compound and then sulfur 6. How did this 6 come about? We calculate the oxidation number of sulfur in SO3. That is S plus, the oxidation number of oxygen is minus 2 multiplied by 3. So S minus 6 is equals to 0. So that S, which is the oxidation number of sulfur, is equals to plus 6. So the compound is addressed as sulfur 6 oxide. The few things you need to understand while trying to name binary compound is, first you need to identify the least electronegative element. Then you need to determine the oxidation number of the least electronegative element. And finally, you need to understand that the more electronegative element is named by adding IDE, which is in this case oxide instead of oxygen, and in the case of nitrogen compound we have dinitrogen 4 oxide instead of nitrogen oxygen. I think that's all for today. In the next class we will proceed from here. Thank you. I thank you for joining us today. Hope you've learned one or two things. And do not forget, if you have any question, you can drop it at the comment section. Any question at all in sciences, don't forget to drop, and also don't forget to subscribe.